At least I hope I am going to start recording. It says we're recording. Hallelujah. All right, so let me share my screen. And what I would like to do is this is going to be basically a review of chapters 17 and 20. I want you to go through all of the steps, the 8 steps that we did, and tell me what you, and the other thing that I want to do, I did notice in chapter 18, which I've taken away, that they did ask about confidence interval. So I want to do both a confidence interval and a hypothesis test. Essentially, this is what you're going to have to do for your final project. And so we will go ahead and do both of these kind of at the same time. So, all right, here's our first example. Let me make this a little bit bigger. Oh, that's in the way. Okay, Wireless Association says the mean cell phone bill is $50.64 in 2004. Market researcher believes a cell phone bill is different today, but unsure if they are higher or lower. The market researcher phones 12 cell phone subscribers and gets the following results. Assuming the population standard deviation is 1849 and using alpha as 0.05, find out if the market researchers' beliefs are correct. And then we've given you the actual raw data. Okay, so this would be just like you collected it yourself. All right, so step number 1 is what?
Find out if it's categorical or quantitative.
That's step number 2. Although you can do that here if you want. We could do that as step number 1.
And list out your numbers.
Yeah, list out your numbers. That's what we should be doing. Okay, so list the numbers. Okay. So I'm going to take more of a back seat and say you guys drive this and tell me what to put here.
Well, we've got an alpha of 0.05. The number is 12, probably. And then we have a mean. I'm guessing it's a mu for 50.64.
We hear somebody in the background. I don't know who's, is that Tori or somebody else?
I'm at work.
G. Oh, you're at work? Okay, are there any other numbers?
And sigma is 18.49.
Sigma equals 18.49. Okay, is that all you see? There should be one more, but if you don't see it, we'll go to the next step, and then you'll be like, oh yeah, I need to know that. So maybe we'll just go to the next step. Step number 2 is what?
This is quantitative data.
Live categorical. And Caitlin says it's quantitative. Okay. Anybody disagree? Okay. Step number 3.
Is it alternative and null hypothesis?
On the null the alternative. So the null is, and the alternative is.
Is the null? Sorry, go ahead.
Oh, I always talk. You can go.
You're good. So then is the null mu equals 50.64?
So you're supposed to say that it is not. It's not Jeopardy, is it?
Oh, sorry.
Mu equals 50.64. Then the alternative.
This is mu equals, but with the dash in it, 50.64. I don't know what to call that. Unequals?
It's not equal. And I don't, it's hard for me to draw the not equal sign, so I use a greater than and a less than sign together. Or you could also do, some people do this, not equal to $50.64. Does anybody disagree? Okay, well done, Carter and Caitlin. Next step.
Would you choose the z-test because we know the population standard deviation?
Pick the test. Okay, so this is where I want you to pick the test. So Tori, you're going with the z-test. Z-test. Okay, and because we know population standard deviation. Okay. Now, so that's good. I would also like you to pick the confidence interval. So actually, before we pick the confidence interval, because then you could do so the confidence interval and the hypothesis test, the same assumptions you would use in the same thing. So since we picked the z-test for the population test, we're also going to pick a z confidence interval. But at this point, what I want to make sure that you can do is tell me the right equations for both. So let's go with the z-test for the for this one. What is the actual equation? And you're welcome to look at your formula sheets for that. By the way, while you guys are thinking about it, I gave my first test today in my college algebra class, which meets right before this class. And they put in there, if you have any problems, call me immediately. And I've had 2 people call me. I got kicked out of the test. What's going to happen? And they got right back in. But anyway, so so you guys aren't the guinea pigs.
What software did you end up using?
Proctorio. So we'll probably do that again. Just as a quick diversion here, since I'm getting a little bit of experience in my college algebra class, we'll probably have the written take-home part, and then we will have the computer part. Oh, I didn't think about that. We can do multiple choice in our class. So I will probably have some multiple choice and some show your work. And then I will also have the computer part. So the computer part will be basically a take-home test, and the written part will be, I don't know, it'll be Canvas. I don't know how we're going to do that. This class is different than that class. But anyway, basically what they have to do is they have to have a web camera on themselves during the test, here, let me go back on camera for just a second. So basically, I've posted the test with Proctorio on Canvas. They're going through, I made it optional. Some people don't have a printer, so you don't have to print it. But if you have a printer, you can print it. And then at the end of the test, you're supposed to go, okay, here's my page 1, okay? And then here's my page 2. And then isn't this a great test? This is my page 3, okay? And here's my ID, so you could know that it was me. And then they're gonna take pictures of their work like this, and then put it in a Word document and save it as a PDF and then upload that. So it's been a real challenge to get it working. Hopefully your test won't be as bad, so we'll see how it goes. But anyway, so just be glad you're not the guinea pig, I guess. Let me go back to my thing here. Okay, what's the equation that we're going to pick for the z-test for this problem?
Rick, I have a question.
Okay, that's Rachel.
You said we were missing a
I'm
number.
getting to know your voices.
You said we were missing a number, but we would figure it out in the next step. Have we figured that out? I don't.
Well, this is the step where you'll figure it out, hopefully, if you can give me the right equation.
Oh.
Well, we can't use like the original z equation because we don't have the sample mean. So do you want us to find the sample mean from the numbers that you listed below?
Ah, okay. I see. I told you you'd figure it out. Yes. We
I
need
just
the
didn't want to do
sample
the work.
mean. We need the sample mean, and I gave you the raw data, but you can figure out what the sample mean is, right? From the raw numbers?
Yes, we can. We add them up
Okay.
and then divide by number.
All right, so I'm going to pull up Excel here. We'll show you how to do this kind of with Excel and on paper. So I'm going to paste this here. Is it going to paste properly? No, I'm going to fix it. Delimited. It has a comma in between. Okay, so there's your raw data. How do we find out our mean, our sample mean in Excel?
You do the average button.
And then you say, curse Bill Gates, right? All right, so I've got a mean of $65 and a penny. Okay, and so that's going to be here. I'll just put it here. Your X bar equals, and you're welcome to use the whole data here. Let's see if I can just paste it. Yeah, okay, perfect. Okay, so that was the number that we were missing because I had given you the raw data. Now, another thing that you could do if you wanted to, you could also figure out the standard deviation. Now, do you need that for this problem? I'm going to do it anyway. Let me just say this. Whenever you get a data set, you should almost always just routinely find the mean and the standard deviation. So I'm going to find that. And which standard deviation is this?
Sample standard deviation.
And what letter do I use for sample standard deviation?
S.
Okay. So I've got my sample mean,
Question.
my sample standard deviation. Yes, go ahead.
On tests, do you still want us to find it by hand, or can we just do that?
No. No, if I ask you to find it by hand, it will only be on the final again, just to make sure you remember how to do it. We'll see. I don't know if I'll ask you that. But, all right. So now, yeah, at this point, yeah, you should be able to find it. Now, let's see, I'm trying to remember who was the one who had the crappy calculator. Was that Jessica? I can't remember who had the bad calculator. But at this point, you should be able to have a scientific or a statistical calculator, and you theoretically should be able to put all this data in there, and it will tell you your standard deviation. And if you don't know how to do that, go to YouTube and say, how do I find standard deviation with, and then whatever your model number of your calculator is, and I almost guarantee that somebody will show you how to do it on YouTube. So, but yeah, for the most part, I only care about Excel. And so this type of a problem would probably be more of a computer problem since I gave you the raw data. Okay. All right, so what's the equation that we're supposed to use on step number 4?
It should be mean, the sample mean minus population mean.
So Z equals, right?
Yeah.
And then what's the letter?
Sample mean X bar
X bar
minus mu
mu
over standard
by
deviation.
which one?
The sigma one, population.
Sigma
Divided by square root of n.
Square root of n. Okay. All right, so that's our Z test. Do you know if instead of doing a hypothesis test, you were doing a confidence interval, what would be the correct formula for the confidence interval you would do at this step?
X bar plus or minus, is it that one?
I hope so.
Plus or minus Z times alpha divided by 2.
Z sub alpha over 2 times.
I don't remember this part.
It's on your formula sheet.
Times sigma divided by the square root of n.
Okay, perfect. Thanks, Carter. All right, so I'm going to copy both of these over to Excel. Okay, so we'll do our confidence interval over here, and we will do our Z formula here. Okay, maybe I should copy all these other numbers over too. I think I will. Okay, so here are all the numbers that we're going to need. Okay. All right, so who haven't we picked on today? Who's been quiet? Jessica, it must be your turn. Can you plug in these numbers?
Yes. So 65.014.
Okay. Minus.
Plus or minus.
My phone's ringing. I have a feeling this is a student panicking. Just 1 second. Hello? Oh, well, just whatever it takes. Yeah. All right. Sorry about that. That was a student panicking about the test. So, okay. So let's see here. X bar minus mu, and mu in this case is what?
50.64.
50.64. Okay.
Divided by 18.49 over the square root of 12.
Okay, so you'll notice on the spreadsheet I did the numerator and the denominator. You can underline those if you want it to look like a fraction. And then we'll take the numerator divided by the denominator, and we've got an answer of 2.693. that right? Yep. Okay. I should have told my other class that I was in a teaching at 10 o'clock. Okay, so that's my z-score. Okay, so let's also, while we're at it, let's do our confidence interval. We're going to pick on Faith. I haven't talked to you today. So how could we do the lower and the upper for our confidence interval?
Well, you just plug in the numbers for like the lower one is like the minus and then the upper is plus.
Okay.
You want me to
So
plug
okay,
them?
there's actually, so I guess if you're doing a confidence interval, there's one other number we need to do before we can plug it in, and that's going to be your z sub alpha over 2. Okay. And in fact, let me talk about the two ways to figure out that answer. You've got your chart and you've got your computer.
What's
Now, most of you are probably going to be more familiar with the chart. Go ahead.
What's the confidence interval that you want us to use?
Well, we've got an alpha of 0.05, so what would be our confidence interval?
Is it 99%?
0.05?
95%?
95%, right. Okay. So you should be able to look on your chart and
Did you put up the formula sheet for us to be able to print out on Canvas?
I put it up like the first week of class. Just if you don't have it printed out, if you go to Canvas, show you where it is. Oh, it does this every day. Approve, I say. There we go. Okay, so if you go to 1040 and then announcements, and then if you go to the very bottom, formulas for tests and quizzes right there.
Okay.
And then you can open it up. So I'll go ahead and open it up here. So you guys are welcome to print that out. You're welcome to use it on tests and quizzes. I just ask that you don't write anything on it, anything extra on it. Keep it pristine. And all right, so we've got your confidence interval formulas. They're all right there. Okay. Now we need to go to the normal distribution page. Okay. Now, I can't remember if I've showed you this, but we're doing a 95% confidence interval, which happens to be right there, okay? So you can figure out the critical value in this case is 1.96, okay? Now, have I showed you guys what if I do a confidence interval that's not on here, like 80%? Would you know what to do?
Yes.
Okay.
Don't you oh, you do like 0.20, but then it's like double-sided.
Yeah. Yeah. So if I did an 80% confidence interval, you would have 80% in both tails. Right now I've only got one tail highlighted here. So half is in each tail, so that would be 10% in each tail, right? For an alpha of 20%. And then what?
Divide it by 2?
divide the 20% by 2, which is
0.1.
0.1 or 10%. Okay, and then what?
You find it in the p-values, right?
Yeah, so we would look for 10% on our chart, which would be, that's as close to 10% as you're going to get that value there. Okay, so that value there corresponds to a z-score of negative 1.2, and then if I go up to the top here, 8. Okay, does that make sense?
Is
So if
anyone
it's
else
negative
hearing that noise?
1.28, it's also positive 1.28. Say that again, Caitlin.
Oh, are you guys hearing that noise coming from the microphone?
I only heard some strange noises when you were talking, and I heard some background. I thought it was just because you were at work. I don't hear anything otherwise.
No, your voice sounds like a robot.
Oh, it does? Does it sound like a robot to anybody else?
It must just be from my end.
Yeah, probably. All right.
Sorry, can you repeat those steps one more time? Just the, like how you would find an 80% confidence interval. Can you just like really quick?
Okay, so, well, I'm going to do it in a, yeah, so if I'm looking for an 80% confidence interval, it's not on my chart. Okay. So if I want an 80% confidence interval, I'm going to cut 80% or my alpha in half. So my alpha for 80% would be 20%. So 20% divided by 2 is I want 10% in the left tail and I want 10% in the right tail. So then I have to go find 10% on my chart. 10% on my chart, that's as close to 10 as you're going to get. And so that's going to be negative 1.28. And of course, since it's symmetric, it will also be positive 1.28. You'll notice in this case, all my critical values, we always use the positive value. And since this is negative 1.28, I can just make it positive because we're going to, that's where these add and subtract comes from. One's positive and one's negative. Okay. Now, you're going to do the similar sort of thing with the computer. If you didn't have your chart, how would you find out that? So we know that based on the chart, we know that the value is 1.96. What would the value be with the computer? How would you find that value? Do you guys know?
Is it norm s dist?
Okay, so norm s dist gives you the probability from the z-score, but you want to get the z-score from the probability.
Oh yeah.
So it's going to be norm s inverse. Okay, so I'm going to equal norm s inverse. So by the way, there's one with periods and there's one without. Use the one without, it's a little bit easier to use. What do I put in here for the probability? How much do I want in the tail for a 95% confidence interval?
10%.
So we're back to our 95% confidence interval. But yeah, so if I were doing it for an 80% confidence interval, I could put 10% in here. And then I would get negative 1.28. Okay. Now normally we use the positive value. Two things I could do is I could just say, well, I want that to be negative. And now it's positive. But how would I do it? So let's do it again. So how would I do it for a 95% confidence interval?
Would you do 0.025 or just 0.05?
Well, that's a good question. That was my question for you. You're not supposed to ask my questions, Rachel. What do you think? If you were to guess, which one would be the correct? Yeah, 0.025. Okay. Now, another thing, now this is going to give me the negative value, right? Another thing that I could do is I could take that 0.025 and I could add it to the 95 and I could get 0.975, because that would leave 2.5% to the right. Okay, and that would give me the positive version of that number. So lots of ways to do that with the computer. Just don't get confused. If you want to do it the easy way and just do that and then just go, oh yeah, I want to make it negative, then that's probably the easiest thing. So the computer is going to be a little bit more accurate than the chart. Basically, the rule is on the paper test, when I give you guys a paper test, I want to use the chart. On the computer, you can use the computer. Does that make sense? Okay. All right. So did Faith ever finish this question? I don't remember if she did. Well, I don't have an answer here, so she didn't finish it. Okay. So how would we do this?
We'll plug in the numbers.
Okay.
So X bar, is it 65.01?
Okay.
And then plus, 1.
So on the lower, we usually go with the minus first.
Oh, sorry, I thought we were doing upper. Okay, minus 1.96.
1.96
times 18.49.
18.49. I can't make that clickable, but okay, 18.49 divided by
the square root of 12.
Okay. Now the easiest thing to do is if you copy that in your formula bar here, copy it, you can paste it, and then all we have to do is change that minus to a plus. Okay. All right, so there's my confidence interval. This is my z-score. Okay. So z-score of 2.693, I'll put that back on our paper here. We'll go back to here. So z equals 2 points, what did I say? 693. Okay. So that's going to be the important part. My confidence interval here, I'll just copy and paste those here. Oops. Okay. Step number 5.
Is it the conclusion?
Not yet. That's step 6, I think, isn't it?
Oh.
Find the p-value.
Find the p-value. And so how do I find the p-value? There should be 2 methods, the chart and Excel, right?
So you can look at the table and then do 1, subtract the table number. And then on the computer, you do 1, subtract norm dist.
Okay, so here's what I'm going to say. I'm going to add a thing here. What would Rick do?
Draw a picture.
Draw a picture, okay? Because I don't know if I need to subtract it from 1 or not. How do you know that, Carter? Because this is where most people get stuck and they don't draw the picture, so they don't know.
Do we have to double it?
Oh, and then the other question is, do we have to double it? That's another good question. Okay, I'm going to try really hard to draw. Oh, that's almost a bell curve. Let's try that again. How do you draw these darn things? I've done it before.
Do a straight line across the bottom and then pull it up.
There we go. There's our bell curve. Okay. Now, So in this case, we need to look at our alternative hypothesis before we finish our bell curve. Our alternative hypothesis is not equal to. So am I doing a one or a two-tailed test?
Two-tailed.
We're going to do a two-tailed test. So I need two tails on here. Oops. Oh, man. I made my bell curve skewed. I don't care. I'm going to leave it. Pretend that's symmetric. Okay? So we need to get this area into the two-tailed area here. Oops. Okay? So this one we are going to multiply by 2. Okay? Now the problem is I've got a z-score of 2.9693, right? So this is my 2.693. That's my z-score. And when I look at my table, what does my table tell me? Tells me the area to the left. So was Carter correct in doing the 1 minus norm s dist?
Yes.
Yes, he was. Okay. So in this case, let's get our p-value here. P-value. So it's going to be 1 minus norm s dist of that value there. Okay. And then do we need to double it?
Yes,
Yes, because
because the alternative hypothesis does not equal.
it's a two-tailed test, right?
Yeah.
Okay, so my p-value is 0.007. Okay. Now 0.007. Okay, so I can put that back here. All right, there's where I wanted to go. Okay. So step number 5, Excel p-value equals 0.0071. Okay. Now, how would we do that with the chart? Do you guys know? Should I pick on somebody? Caitlin, it must be your turn.
You would plug in the z-score into the chart.
Okay. So I've got a z-score of 2.693. So 2.69, I guess we'll have to go. So that's going to be the last number here. So I got a value of 0.9964, right? So with the chart, I need to subtract it from 1 though. 1 minus 0.9964 with my fancy dancy calculator. 0.0036, and then I need to double that. It's 0.0072, so it's slightly different. That's pretty good. And then I need to multiply that times 2. Equals that. Okay, so your answer is slightly different on whether you use the chart or the p-value. Okay. Step number 6 is, whose turn is it now? Okay, go ahead. I don't know who me was. In the background voice. Let's go with Jessica.
It would be not significant because it's less than alpha. Is that what we're
So we
doing?
need to compare to alpha. Okay, so we're comparing our p-value to the alpha. And then, so step 7 was reject or not. And you say?
Reject.
Reject the null. Okay. So the null said, as just a reminder, the mean cell phone bill is $50.64. We've rejected that. We therefore think that the mean is not $50.64. Okay. So our conclusion is
There is not enough evidence to show that the mean cell phone bill is $50.64.
there is not enough evidence that the mean cell phone bill is $50.64. Now, if we were in class, I'd ask you to raise your hand if you agreed with that. So instead of that, I will say, does anybody disagree with that?
I thought if you rejected it, there is evidence.
Oh, so Carter disagrees.
Too.
This is where I really need to have a poll. Who's right?
Is it
Carter.
not?
Say that again, Jessica or Rachel.
You said the other day, like the not is not. So would rejecting be the not? So there's not enough evidence, or
No, do not reject, not enough evidence.
Do not reject, there is not evidence. So if you do reject, there is evidence. So Carter was correct. So Carter, give yourself a pat on the back. Well done. Okay. Does that make sense? Okay, now. So here's what I would like to say though. This is a little bit vague. I know that's what they would say, and that's kind of how I've taught you up to this point. Okay. Do we know if the cell phone bill is higher or lower than $50.64? Do you want me to answer that? I'm going to answer it. We do know that the mean is either higher or lower. How do we know that? Or how do I know that? Let's look back at our numbers. I know my numbers are all here on this page. How does Rick know that the cell phone bill is higher or lower? And if it's higher or lower, is it higher or is it lower than $50.64? I have a feeling Tori will answer this question correctly.
Can you remind me of the question?
Is the cell phone bill higher or lower than $50.64?
I would say there is enough evidence that the mean phone bill is greater or not equal to, wait, is,
Yeah, well, I don't want you
Uh-huh.
to say not equal to. I know we've been kind of trained to do that, but what I wanted to go to the next step. Okay, so yes, it's not equal to $50.64, but is it higher or is it lower?
it's higher
Higher because
the mean that we got from the sample was higher.
yeah, it was $65, right? So my sample mean said, yeah, it's $65. It's gone up. And we have good proof, because that's a very small p-value, that it's gone up. Okay. So when you're doing these conclusions, especially on a two-tailed one, so there is enough cell phone, there is enough evidence that the mean cell phone bill has increased above $50.64. So I'd like you to be a little bit more specific on those two-tailed ones. Does that make sense? Because you should be able to know if it's higher or lower. Now, let me also ask you this question, okay? So this is based on the hypothesis test. Can you get the same conclusion with the confidence interval? I'm gonna make this a little bit smaller so you can see the confidence interval there. So if instead of asking you to do a hypothesis test, so I'm going to skip all of these. In fact, I'm going to erase that for a minute. Can you get the conclusion that the mean cell phone bill has increased based solely on the confidence interval? And I'm going to say yes, and I want you guys to tell me why.
It's because both of them are above the population mean.
That's right. Both of these numbers are above $50.64. So you could say, in the past we've said we are 95% confident that the mean cell phone bill is between, and I'll put these into dollars here, $54.55 and $75.48. This is ample evidence the bill has increased above $64. Okay, so theoretically, yeah, you can do this either with a confidence interval or with a hypothesis test because of your p-value. Does that make sense? Okay.
Yes, it makes sense.
All right, let's move on to another one. All
Can
right,
we do
so
another T one?
well, let's see if this next one is a T one. Okay. So fun size Snicker bar, and we're going to have to move a little bit faster because we've only got 20 minutes left. Fun size Snicker bars are supposed to weigh 20 grams. The punishment for selling candy bars less than 20 grams is severe, so the manufacturer calibrates the machine at 20.1 grams. Well, that's interesting. Quality control is concerned about calibration, so she obtains 11 bars to test. Shutting down the machine is expensive, so she uses an alpha equal 0.01. Assume the weights come from a normal distribution. Okay, step number one is find the numbers. Okay, what are the numbers I need here?
Is mu 20.1?
You guys are always playing Jeopardy with me here. You're supposed to say the mu is. Now this one's a little bit of a tricky one. Are we comparing it to 20.1 or are we comparing it to the label weight?
The 20 grams is the population mean, because that's like what it should be.
That's what it should be. So you could argue it both ways, but you're not going to get in trouble if it's below 20.1. You are going to get in trouble if it's below 20, right? So, because that's what you've put on the label. So I would go with 20 on that one. Does that make sense, Tori?
Yeah, that does.
Okay. Next, what are the other numbers?
You got 11 for number.
So n equals 11, your sample size.
Alpha 0.01.
Equals 0.01.
Would it be safe to say that the X bar is 20.1?
Is the X bar 20.1?
No, wouldn't it be the mean of all the data they give us?
Yeah, we're going to have to find our data.
I didn't
Let's
even
use our
see that.
data. Okay. So if we find our data, we'll put that on a new page. Oh, I thought it was going to put that in columns for me. Text to columns. It's delimited with a bunch of commas. Finish. So we get data, we're going to find the mean and the standard deviation just because that's what we always do. The mean is 20.3 and the standard deviation is 0.064. Okay, so we're going to add those two numbers to our stuff here. So the X bar mean, okay. All right. Then, are there any other numbers we need?
Those are the only numbers we need.
Okay, so step 2. Is it quantitative or categorical?
It's quantitative.
Quantitative. Step number 3 is the null, the alternative. Null is, and the alternative is.
Is mu equals 20?
Mu equals 20, more Jeopardy. That was a question, not a confident answer. Okay, and the alternative?
Mu is less than 20?
Mu is less than 20, and you said less than because?
Because it says they're worried about calibration.
Yeah, they're concerned about, yeah, we definitely don't want to be below 20. Okay, now are we below 20?
No.
No, but we're very close to 20, right? So it's hard to tell if that's a significant difference, right? But right now it looks like we're probably not going to be less than 20. So what do you think we're going to do? Are we going to reject the null or are we going to not reject the null?
Reject it.
See, I would say we would probably not reject it.
Oh, sorry.
It's not,
I meant
because 20.3 is not less than, yeah. Oh, it's only that we always come, when we talk about rejecting, we're only talking about the null. It's reject the null or not reject the null. We don't, that's why I say we don't use the A word. We don't accept the alternative. We either reject the null or we don't reject the null. Okay. All right, step number 4. Find the test or confidence interval. Okay. So what should it be in this case?
A t-test?
A t-test because
We don't have a population standard deviation.
have population standard deviation. Okay, and so the formula for the hypothesis test formula is t equals what do you guys think? It must be Faith's turn.
Can you repeat the question?
What's the formula for the t-test?
Oh, I don't have the formula sheet. I think I don't know.
Okay, who has the formula sheet and can tell us?
I
Is
do.
it? Oh,
Just-
go ahead.
Well, this one's from like a practice that we did, so you guys can go. It's fine.
It's t equals x bar minus mu divided by sample standard deviation divided by square root n.
And sample standard deviation is what letter?
Sigma?
S.
S.
S. It's S. That's why I asked that question, because I want to make sure you guys know. S divided by the square root of n. Okay. Now, if I'm doing the confidence interval formula, what's the confidence interval formula?
Is it the same as if we're doing the problems for the x? So is it x bar plus or minus z?
Not z.
Oh, is it t?
It's going to be a t, right? T sub alpha over 2
Okay.
times
Times s
s
divided by square root of n.
divided by the square root of n. Perfect. Okay. All right, so I'm going to copy both of those over. We will do these on Excel because it's easier for you to see, but you should be able to do these on paper as well. Okay. So I'm going to move this over here. Now, there's one number we're missing. Do you guys know what the number is that we're missing?
Z.
We are missing Z, but we're supposed to be missing Z because it's not a Z test. Let's do the confidence interval first, and then you'll know what number you're missing. We did the lower and the upper. And I need to figure out my T sub alpha over 2. I'm going to go to my chart. So here's my T chart. How do I find my critical value? My T sub alpha over 2.
Do we have to find t first by doing like x bar minus mu?
You don't have to do that first. That's good to know, but that doesn't help the chart because, well, do it if you want. Equals, there was a reason why I wanted to do the confidence interval first, but if you want to do this first. So X bar is going to be 20.3 minus 20, and then S is going to be S divided by the square root of, my N was 11, right? I should make sure that my N was really 11. So just so you know, sometimes on the test, I'll say that there's 11 and then I'll only give you 10 or something. So count whatever the data is. So my n definitely was 11 in this case. Okay. And in fact, let me copy all these other numbers here. I already got those. Okay. Now, okay, so then I've got the numerator divided by the denominator. This is my t-score. Okay. Now, if we're going back to here, okay, so I found my t-score. In this case, what was it again? I forgot. It was 1.55. Okay, so step number 5 is what? Find the p-value. Okay, so whether I had done the confidence interval first or the p-value now, you're going to figure out the number that you're missing. Okay, so how do I find the p-value on this chart? Do you guys know? You guys definitely want a hint, don't you? Okay, how do I find the p-value with Excel? I'm going to copy my null alternative hypothesis here. What's the formula I use for my t-score? Let's look back here. Those are all your Excel commands. What do I use?
It's t.dist.
T.dist. Is it t.dist right tail or left tail?
I don't know.
How do we know that? We know that based on our
left, isn't it?
alternative. It's less than, so it's going to be a left tail test, right? Okay, so if I'm doing a left tail test, t.dist, which is the left tail test?
Just the t.dist.
Just the t.dist. What do I put in for x? Tori, save me.
I don't know.
Don't know. Caitlin, save me.
Your x is the number 11.
No.
Shoot.
X. I'm like, what?
Yeah, this is where Excel messes up. It should say T. It's your t-score.
If I say it with enough
1.55.
confidence, I'm right.
Okay, so then what's the next number I need to know?
N minus 1.
N minus 1, your degrees of freedom is N minus 1. So if my N is 11, I want 10 degrees of freedom. That's what I've been trying to get you guys to do ever since I said, find this confidence interval. You got to know your degrees of freedom. Okay. And then what do I put here? True or false?
True.
Always true.
Always true. Okay. So my degrees of freedom equals 10. Okay. N minus 1. Okay. Now let's go back here. So I got a big p-value there. Do I need to double that?
You do not need to double that because it is not
No.
a two-tailed test.
That's correct. Do not double. Okay. How do you know? You drew your picture. And in this case, I'm going to do this. I'm going to refill. If I can find my bucket, that's going to be white again. Why won't it let me fill that in? Okay, then I'll do it this way. I want everything to the left of, it won't let me color on top of that. Everything to the left of this. Okay. And I no longer have a z-score here. Whoops. I no longer have a z-score. I have a t-score. Oh my gosh. I'm really having trouble with that. T equals 1.55 with degrees of freedom equal to 10. Okay. All right. So now that's the Excel method if I'm using the chart. Okay. Do you guys know how to use the chart on this case?
Yes.
Okay. How do I find the p-value now with the chart?
You go to 10 under degrees of freedom.
10 degrees of freedom. I'm going to be looking at this line. There's a typo on that chart. I didn't notice that. Wonder how that got on there.
And then you go between 1.372 and 1.812.
Yes, 1.55 is in between those two numbers. So this tells me the area to the right.
Wait, where did 1.55 come from?
55 was my t-score that I calculated with my t-bar, x bar minus mu over s over the square root of n. So that's my numerator, that's my denominator, that's my t-score. Okay. So 1.55 is in between those two numbers. So the area to the right is in between those two numbers. Now, so what does that mean?
Because it's 1.55, don't you round closer to 1.812?
No, don't round. Okay, so remember this is telling me the area to the right. I want the area to the left. Okay, so if the area to the right is in between 1.372, 0.10 and 0.05, okay, well the area to the left is going to be in between 95% and 90%. So your p-value in this case, your chart is going to be 0.95 less than p-value less than 0.90. So your p-value is in between 90 and 95%, which is exactly what we got. So that one was kind of a tricky one, wasn't it? Okay. Let's go back to our confidence interval for a moment. Okay, how do we calculate our confidence interval? It's going to be x bar, which is right here. Oh, actually, minus, if we're doing a 95% confidence interval, actually, what's my alpha? My alpha is 0.01. What should my confidence interval be? A 99% confidence interval. Does that make sense? If my alpha is 0.01, I'm going to use 99%. So my 99% confidence interval, how do I find that value? 10 degrees of freedom. I want this to be 0.01. So that's going to be 2.764. Okay. So my T sub alpha over 2 equals 2.764. I can also find it with T dot inverse. If I use a two-tailed confidence interval, the probability is 0.01 with 10 degrees of freedom. Oh, what? Why is that number so off? Oh, you know what? This is actually wrong because I don't want to use the 0.01 column. I want to use the 0.005 column. So with 10 degrees of freedom, that should be 3.169. Now those numbers are closer. Okay, that's your chart. That's your Excel. Okay. So if I use Excel on this, I'm going to get my mean minus T sub alpha over 2 times S is standard deviation, divided by the square root of my N is 11. Okay. Then I can do that, copy, paste, change that minus to a plus. Okay. All right, so now let's go back to here. I'm going to copy that. That's my confidence interval. And I'm hurrying a little bit because I know we're out of time. That's my confidence interval. My p-value in this case is going to be this or that. Okay. Step number 6, compare to alpha of 0.01. Step number 7, let's pick on Jessica. What do we do? Did I pick on you last time? I think I did. Let's pick on Carter. Reject or not?
Yeah, reject.
So 0.92 is less than 0.01?
Oh, just kidding. Sorry, I was looking at the chart. So if it's not, so it is in between 0.95 and 0.90?
Right.
Okay.
Which either way, both of those numbers are greater than 0.01, right?
Mm-hmm.
So therefore I do what?
Do not reject.
Do not reject. Okay, and your conclusion?
There's not enough evidence.
There is not enough evidence that the mean weight is less than 20 grams. Okay, we got 20.3, but that's not much difference, right? Now, could we do that conclusion with the confidence interval? We are 99% confident that the weight is in between these two values here, right? 19.6 and 20.9 grams. 19.6 and 20.9 grams. Okay. Is that significant evidence that it's above 20? Rachel?
No.
No, because it could be as low as
19.6.
19.6. Okay, so even though in our case we got a value of 20.3, right? It appeared from our sample that we were above weight, but based on the margin of error, it could be as low as 19.6. So we still might be cheating our customers, even though we got 20.3 grams, right?
I have a question.
Okay.
Based on the data, we saw that there were some less than 20 grams. So why would we
Correct.
have to do this when we already know that some of the customers are being cheated?
Okay, that's a good question. We've got some that are low, right? Yeah, so that's a good question from a practical point of view. Yeah, that's a good question to ask. Our mean looks pretty good, but yeah, there are some customers. So I will tell you from a manufacturing standpoint, I used to work at a vitamin company, and supposedly this was one of the best quality companies, and they said, well, if your mean is okay for I think they said if it was more, Their limits were if it was 5% below or 15% above, then you're okay. So a lot of times we talk about the mean weight. The mean weight was okay. Yeah, you might cheat a couple of customers, but one way to look at it is 1, 2, 3, 4, 5. So about half. So 5 out of 11. That's about half your customers are getting underweight. Okay. So it sounds like we need to set our machine even higher than 20.3 because some of these aren't getting in there. So. But why would you do this? Because it's a statistical test and I'm trying to show you how confidence intervals and these things work. Now, by the way, what about your sample size? Is your sample size large enough?
No.
No, but is it okay if I assume my weights are normal?
Yes.
Okay, it is okay. But yeah, and it's pretty small sample size, right? But the reason why they use it is because shutting down the machine is expensive. So that's why they kept a small sample size. Okay. All right, so those are 2 questions there. Do you feel like you can handle chapter 20? Rachel, how do you feel?
Like a 7 out of 10. About that.
Okay. All right. Well, I will post this. I think did I just have 2 on here? I thought I had more than 2. Okay, so I will post this up as a review. So your quiz on Tuesday will be on chapter 20. It will focus mostly on the T, not the Z, but I do want you to be able, because on the test, I'm going to mix them up and I'm not going to tell you which is which. So I just wanted to practice that. So any last questions before I let you go?
Are you going to post this review that we just did on Canvas?
The video?
Yeah, like, well, the lecture notes.
Yeah, and the lecture notes, yeah.
Okay, and can you post the Excel sheet as well?
Oh, you want the Excel sheet too? Okay, I wasn't going to do that, but I can do that.
Okay, thank you.
Uh-huh. I can do that. All right, thanks. See you
Thanks.
all on Tuesday.
Thank you.
And have a great one. And make sure you get all your data collected, because this is the kind of stuff you're going to want to be doing. Okay, see you all on Tuesday.